Hi there, Spark fans. Rob Reynolds here to help you jump into the new SIK 4.1. Now, I want to point out that these experiments will also work if you're using the SIK 4.0. However, I make no guarantee, express or implied, regarding a 4.2, 4.3, 4.5, or any other future iteration of the SIK. So let's get started. The first thing you'll need to do, and you can do this before your kit even arrives, is to download and install the Arduino IDE. That stands for Integrated Development Environment, and that's going to be the tool you use to code and upload everything to your SIK. You can grab that over at arduino.cc. So let's go over there, download and install that, and then we can start with our first circuit. Hey Rob, you have to tell them about the new driver. Oh, the what? The new driver. See, since the SIK 4.1 comes with the Redboard Quick, they're going to need to install or at least upgrade their CH340 drivers. Well, shouldn't that be installed automatically? Well, maybe, maybe not, and it's better to be safe than frustrated. I tell you what, you relax, grab a cold beverage, I'm going to go walk them through installing the 340 drivers, and I'll send them back when I'm done. Okay, thanks. Hi there, Spark fans, Rob Reynolds here. For years now, we've been able to run many of our boards without really having to think that much about drivers, or by simply installing the good old FTDI package and calling it good. But that's starting to change as more boards are using the CH340 chip. Some of those boards here at SparkFun include the SparkFun Redboard Quick, the Redboard Artemis and Artemis ATP, a couple of our SparkFun serial breakout basics, and some others. The CH340 driver has been tested on a Windows machine running Windows 7 and Windows 10, on a Mac running High Sierra. It's been tested on Raspbian Buster on a Raspberry Pi, and on Ubuntu 18.04.2 on 64-bit systems. Now, each of these operating systems should have the drivers pre-installed. However, if it's an older install, you may run across problems. So better to be safe than frustrated. So let's just talk about either installing or upgrading whatever package you may or may not have. For a Windows machine, you can download the CH341 SER executable file. When you run it, you'll first need to hit uninstall to remove any older versions that may be lingering. Once that's done, click the install button. Once that's finished, you'll want to verify that the drivers are in fact installed, and you can do that one of two ways. You can head over to Device Manager, go down to Ports, and then open that up and plug in one of the aforementioned boards. You should see a new board pop up labeled USB Serial CH340 something 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 something. And the other way to do it is with your Arduino IDE. Simply go to Tools and drop down to Port, plug in your board, and you should see a new port pop up there. If you're on a Mac, there's something to be aware of before you even begin. With High Sierra, your computer may restart as soon as you plug in a CH340 board. To avoid this, we recommend completely uninstalling the old version and installing the newest version of CH340 drivers before you even plug one of the boards in. That should circumvent that issue. To start, you'll open a terminal window by selecting Go Applications. Open the terminal program under Applications, Utilities, Terminal. Now you need to access the extensions directory. The path is slightly different depending on which OS you're using, but our How to Install CH340 Drivers page has those for you. You'll use the sudo rm-rf command for both the USB and USB serial.kext files to remove these files first. Next, download and extract the CH341 SER_Mac package. Open the package file from the unzipped folder, follow the directions, restart your computer, and you should be good to go. To verify that you're all set, you can either go back into the terminal window and use the ls command, and you should see something like wch USB serial, or of course you can also do it through the Arduino IDE. If you're using Raspbian on your Raspberry Pi, you'll have it the easiest of all. Open your terminal and simply use the good old standby, sudo apt-get update followed by sudo apt-get upgrade. If you're using a different Linux distribution, you'll probably need to download the CH340 drivers for Linux folder. That too is linked over on our How to Install CH340 Drivers page, along with full instructions. Also at the bottom of that page are some troubleshooting tips, should you find yourself running into issues. If you've only used the SparkFun Redboard or Arduino boards up until this point, you are going to need to install these CH340 drivers. I can't stress that enough. Full instructions are available over at sparkfun.com/CH340. And installing them ahead of time is going to shorten the time and the frustration between dreaming of circuits and creating them. Happy hacking, friends! So at this point, you should have the Arduino IDE and the necessary drivers installed, so let's get physical. The first thing you'll want to do is a little bit of assembly. So open up your package. You'll want to take your breadboard, your Redboard, and the base unit. First thing we'll do is take your breadboard. There should be an adhesive backing on that. We'll peel off the protective layer. We're going to place that in a big open field here. 14.5 pounds of pressure, and it should adhere nicely. I totally just made that up. Next thing you'll do is take the breadboard quick. So you want to place your breadboard quick down on your base plate so that your connectors are facing the SparkFun Electronics logo on the base plate itself. Once you've done that, you'll grab your screwdriver and the two little screws. Take out your screwdriver, make sure that the Phillips head end is sticking out. So grab one of your screws, and something important to note here, these standoffs are not pre-threaded, so you may want to remove your breadboard and using a little pressure, get your screw started. Then do that again on one of your opposite standoffs. That's going to make life a little easier. Now, drop the board here, and remembering which standoffs you used, life is much easier this way. Grab the second one, install it, and you're ready to move on. Next, grab your micro USB cable, open that up, plug one end into your breadboard, the other into a USB port on your computer, and you should have lights. Now you may get a little something on the screen saying installing something new, yada yada, blah blah blah, and that should run automatically because you've installed your CH340 drivers. So there's one final step we need to do before we can get started here, and that's to download the SIK code. You can do that over on the SIK install page. Just scroll down to the download link, download that. You'll extract the files and then have to drag them over into your Arduino folder. Take a look at the hookup guide there and that'll give you specific instructions for that. And once that is done, we are ready to get started. So let's grab our guidebook and open up to the first experiment. There's also an online guide, but you're going to find a lot more information in the guidebook itself, so I'm going to suggest using this throughout the course of this. Project 1 is going to give you concepts, including concepts on LEDs and Ohm's law, things like that. But for the experiment itself, let's jump right in. You're going to need a few things for this experiment. You will need an LED. Any color will do, so choose the one you like best. I'm going with blue because that was on top. You'll also need a 330 ohm resistor and a pair of jumper wires. One question I get asked by people just starting out is the jumper wire color important? And the answer is no. They're color coded simply for you so you can tell what's going where. You can color code it however you want, but all jumper wires on the inside are the same, just like people. Before we start putting this all together, there are a couple of things I want to talk about. I want to talk about LEDs and I want to talk about breadboards. Now, an LED is a polarized component, meaning in order to work properly, electricity can only flow through it in one direction. If you take a look at it, you'll notice on the two legs, one is longer than the other. The longer leg is the positive, the shorter is the negative. Now, what happens if you've been working with it and you accidentally snip the legs off to the same length? Ooh, trouble there. Not so. If you take a look at the LED itself, right here on the base, one side has a flat edge. That flat edge is going to be your negative side. Second thing I want to talk about here is our breadboard and how it operates. The breadboard makes putting a circuit together really simple without having to solder. And the way it's designed is such. On either side of the board, you can see you've got a red line and a black line, and that indicates your positive and negative. These holes are connected all the way from here to here, so anything you plug into a hole here on the red side or black side will be connected to anything that you put down here. Now the holes in the center are connected across this way on this axis. There are 5 pins here, 5 pins here, so anything that goes into one of these 5, A, B, C, D, or E, are going to stay connected, and same with F, G, H, I, and J. Those are going to be connected. So in order for a circuit to work, you've got to put your component in this way so that the pins are not connected. If you were to put it in this way, your pins would be on the same line, and that's not going to work for you. All right, now let's start putting stuff together. So first we're going to install our components into the breadboard itself. We'll take your LED and And we're going to want to put that into A1 and A2. And really, it doesn't matter where you put it, but if I'm following along on the guide, the LED is going into A1 and A2. We've got the negative leg, it'll go into A1, positive into A2. Now you may need to bend the leg a little bit, since the positive leg is longer, to make sure they both have contact. And then these will go right in here. Make sure you've got a good connection, and you're all set. Secondly, we'll add the resistor. Now, a resistor is not a polarized component, so it can go in either direction and your power is still going to flow through it. You're going to want to take both of the legs, bend them down like this. Now this resistor is going to go into the positive terminal. So you'll put it over here, and notice how it's jumping across this center line of the breadboard. There is no connection between here and here. You've got a break. So this pin of your resistor is not connected to this pin of your resistor. If that happened, it wouldn't be doing anything. And the final thing we're going to put in is a pair of jumper wires. Again, jumper wire colors don't matter. Choose the ones you like. I'm going to take the yellow one. I'm going to run this from 2, the same line that your resistor is in. And this is going to go over and plug into your pin 13. Just like that. Your other wire, whatever color it is going to go in the A line, and make sure you're on the same half of the breadboard as the LED. And this is going to go over to one of your ground pins. You'll notice a couple of ground pins on this side by your power line. You've also got one over here, right next to 13. Either one will work, any of the 3. And your LED should be blinking. Now why is that? Well, that's because the breadboard ships with the blink code pre-installed. This is your first code. It's basically like the hello world of physical computing. Now let's talk about what we're doing here, and we'll do that by opening up the first example. If you go into your Arduino IDE, go to Files, Examples, SIK Guide Codemaster, SIK Circuit 1A Blink. Open that up, and we can take a look and see exactly what's happening. First, we set up pin mode 13, which is our LED pin, as an output. Now, digital write tells it what to do. High is on, low is off. Now let's change this. We'll see we've got a delay of 2,000. Now that's in milliseconds. 2,000 milliseconds equals 2 seconds. But what if we change this to 500? Change both the delays down to 500. Now you're going to want to make sure that your board is connected properly. So you'll look under Tools, go down to Board, and you should find Arduino/Genuino Uno. Make sure that is selected. And now Port. Take a look at your port. If you have a number of ports, it won't be 1 or 2, but it's probably going to be around 9 or 10, wherever your ports start listing. So click on that. You should be set to go. You can hit Control-U or hit the right arrow, and that's going to upload your code. You'll see it compiling the sketch. You'll see it upload. And once that says done, if we look at our LED, it should be blinking twice as fast now. And it is. Congratulations, you've just coded a circuit. Moving on, let's take a look at circuit 1B. We're going to be introducing a potentiometer, which is this little knob. Notice it turns to the left, it turns to the right. For this, we're also going to need 5 more jumper wires. I'm going to be using a pair of red and black for power and ground, and I'll talk about that a little later. And also 3 wires to hook up the potentiometer. Now before moving on, I want to just mention something about a potentiometer. A potentiometer is an analog device. There are digital devices and analog devices or components. A digital device is either on or off. It's either a 1 or a 0. Think of it as a light switch in your home. An analog device can read anywhere throughout a spectrum. Think of a dimmer switch in your home. Your light can be all the way on, all the way off, or anywhere in between. That's an analog component, and that's what a potentiometer is. So oftentimes in a circuit, when we're setting up multiple components, we may have more power or more ground lines than we have available on our board. That's where the breadboard comes in. We're going to disconnect our ground from our LED. What we'll do now is we'll run a power and ground from the breadboard to the breadboard. So I'm going to take my red line, and again, colors don't matter, but I use red and black for power and ground. just for my own head. So let's go from the 5-volt pin on our red board over to the red side of the power and ground lines on our breadboard. Then we'll take our black wire and do the same thing. We'll run from one of the ground pins on the red board over to the negative or black line on the breadboard. So now if we take the ground from our LED and plug it into the ground line on our breadboard, voila! So now that we have power and ground running to these two lines, we can put in our potentiometer. Notice it has 3 pins. One is going to be ground, one is going to be positive or power, and the one in the center will be the reader. That will read your analog value from 0, in our case, to 1023. So let's plug this in, making sure that our pins are on 3 separate lines. And remember what lines we're on. I am looking at 26, 27, and 28 here. The book says 25, 26, and 27, but again, you can do either. Now, I'm going to take our red line, we'll put this on this end, and this can run straight to the power line on your breadboard. I'm going to take my black wire, put it over here on the ground side of the potentiometer, run that to the ground line on my breadboard, and again, it can be anywhere along this line. Choose your favorite pinhole. And thirdly, we'll take our analog read line. That's going to go right in the center. And notice it's not in the same plane this way, but it's in the proper pin line this way, and that's what's important. Now this is going to go to pin A0. A stands for analog, and those are the pins that can do analog reading. Now what this circuit is going to do is it's going to read the value of the potentiometer, and that is going to determine how quickly or slowly our LED blinks. So let's go over and load up that circuit. Again, under File, Examples, you're going to look down to SIK Circuit 1B potentiometer. Bring that up. Make sure that under Tools, you've got the proper board selected and the proper port selected, and then upload your code. Now once that's done uploading, depending on where your potentiometer is, it may look like your LED is off or all the way on. If we turn it, there we go. All the way this direction, we get a slower blink, but as we move it this way, we get a much quicker blink. What that is doing is shortening the delay time. If you take a look back at the code, you'll notice that the delay doesn't have a number, it says pot position. Up here, integer pot position is being read by the analog pin. Right here in the loop, pot position equals analog read A0. Feeling a little more comfortable with this? Excellent. Let's move on to circuit 1C. We're going to take out our potentiometer and read something in the atmosphere. How about light, since this is our section on light? So we're going to grab 2 components to do this one. We're going to keep this circuit the same. We're going to grab our photoresistor, and that measures light, and a 10K ohm resistor. A photoresistor is a component that reads the amount of light hitting the surface right here. Now this is also an analog component, and what's cool about this circuit is we can leave the wiring as it is because we're just going to be reading another analog component. And what we can do is take out the potentiometer, and we're going to install the photoresistor and the resistor. So what we'll want to do is take our photoresistor, we're going to run this between our power line and our analog read line right here in the circuit. Then we'll take our 10K ohm resistor, bend those wires down once again, and this is going to go from the ground line to the analog read pin. You may need to tweak this a little. You might need to move a jumper wire. So let's go over, upload that code. Once again, go to Files, Example, SIK Guide Codemaster, and Circuit 1C photoresistor. The usual, check just to make sure you're in your proper port and you've got your proper board. Then, over here, and upload. This is a great circuit to demonstrate that we can make things happen. We can change what happens within our circuit without us having to do anything to it. It can simply rely on the environment around it. Great, we're now done uploading. Let's see what happens. We've got our light, looks pretty bright. What happens if I cover this up? And nothing is happening. But there's a way to figure out why. In the Arduino IDE, there's a tool called the serial monitor. If you'll notice here, in our code, we've got serial print line photoresistor. That's going to be printing what our value is from our photoresistor. So if you go up to Tools and drop down, click on Serial Monitor, you should see a string of numbers. Now if I cover up the photoresistor, you'll notice those numbers drop. So let's take a look at our code and see what's happening here. Up here, we've got an integer photoresistor, which sets the baseline of our photoresistor at 0. We also have threshold, which sets its peak at 750. Looking at my range, it's at about 275 to about 70. That's smaller than what we have in our code. So let's set our photoresistor to 65 and threshold to 281, so they'll be in those parameters. Upload your code and let's see if it works. Now, when I cover it, the light comes on. Once I expose it to the light, the LED goes back off. Light goes on, light goes off. Light goes on, light goes off. So as you can see, we're putting a little work on you here. The code, as it is, may not quite work for your circuit depending on the environment around you. You may have to tweak some things, but that's good. That's how we learn. Feeling good about it? Then let's move on to the next circuit. Let's move on to the fourth circuit in the light series. And this is going to bring some new things into the mix, along with combining the old ones. We're going to take both our input components, the photoresistor and our potentiometer, and we're going to add an RGB LED. That stands for red, green, blue light-emitting diode. Now, this is the LED that has 4 pins on the bottom, and it's actually 3 separate LEDs, a red one, a green one, and a blue one, all in that tiny package. And from this, we can make any of 16 million colors simply by varying the amount of light coming from each of the 3 diodes. We're also going to need an additional 5 jumper wires to complete this circuit, along with 2 more 330 ohm resistors to go along with the one we already have in the circuit. One thing I want to point out with these resistors, if you look at your 10K ohm resistor and your 330 ohm resistors, you'll notice that they have different stripe patterns. These stripes indicate the resistance of the component, and that way you can make sure to choose the proper one. Now the concept of this last circuit is pretty simple. We'll still use the photoresistor to turn our LED on and off, but instead of our single color LED, we're going to be using the 3-color LED and varying the amount of each LED to make a multitude of colors. We'll do this by using our potentiometer. Now let's put this circuit together. We'll start by removing our single color LED. We're also going to take this wire out and our control wire out. We can leave them in the board and in our ground line on our breadboard. Let's remove this resistor as well. Now if you look at your RGB LED, you'll notice that the pins are different lengths. The longest pin is your common or your ground line, and that's important to remember. So we'll probably have to separate these pins a little bit to install it on our breadboard. Again, make sure each pin is on its own line. So we've got 1, 2, 3, and 4. Again, make sure you've got a solid connection there. Now remember where your ground line is. In this instance, it's on 3. So your ground wire will go right there. The 5 volts that we're getting from the red board is going to be too much for your LEDs, and you will burn them out eventually. So we're going to put in resistors. That's going to resist the amount of current going to our LED. We'll need one for each of the red, green, and blue lines. So we will bend it like we did earlier. And once again, we will jump it across that center line. So we've got one for that pin. The ground does not need a resistor. One for this pin. There we go. And then throw your third resistor into your remaining pin. Oh, we're in here. There we go. Now we'll install our jumper wires. So from the resistor to the red pin, we're going to go over here to pin number 9. From the resistor to the green pin, we'll go over to pin number 10 on our red board. And finally from the blue pin, or the resistor to the blue pin, we'll go over here to pin out number 11. Lastly, we're going to put in the potentiometer. So we'll put that right in the middle here. I'm using 14, 15, and 16, it looks like. And now, in the earlier experiment, we went directly to the red board, but due to the number of wires we already have going over there, we'll take power and ground to the power and ground line on our breadboard. So again, ground to the ground line. Power to the power line. In this case, the 5-volt line. And thirdly, our analog read line. Now, if you remember earlier, it went to analog 0, but that pin's already taken up. However, as an analog component, to get an analog read, it needs to go to one of our analog pins, so we will put this in analog 1, or A1. And your circuit should look something like that. Let's take a look at the code now. If you open up the SIK Circuit 1D RGB nightlight, you'll see a couple of things. We've got our photoresistor at A0 once again, and now our potentiometer is in A1, and our threshold here is at 700. You'll also notice we've defined our 3 RGB pins, our red pin, our green pin, and our blue pin going into 9, 10, and 11. If you look in our setup, we've got our serial begin. That'll help us if we need our serial monitor. Now we set how our pins are going to be used. The pin mode of each of our red pin, green pin, and blue pins is set to output. Now we go down into the loop, which is where the real things happen. Our photoresistor is on analog read A0. Our potentiometer is giving us an analog read on A1. If we open our serial monitor, we can see here that it will be giving us our photoresistor values and our potentiometer values. Down here, the rest of the code is basically just telling it what colors it's going to make depending on the threshold of your potentiometer. So let's make sure we are on the proper board and COM port. Yep, excellent. Now let's upload that. So let's open our serial monitor now, just so we can watch the fun. There it is. And as you can see, it's giving us our photoresistor values and our potentiometer values. Cover the photoresistor, and that value changes. Move the potentiometer, and that value changes. So to see this circuit in action, you're going to need 2 hands this time. To turn the LED on and off, we're using our photoresistor, just as we were before. But now we add the potentiometer, and that's going to change color. Of course, if you do it without the photoresistor covered, you won't see anything. But cover your photoresistor, your LED comes on. If you slowly move the potentiometer, you'll notice we're going through a number of colors. Now this isn't scrolling through the full 16 million colors that are available because we've set thresholds. But as you can see, depending on where our potentiometer is set, we can determine the mixture of colors that we're using. Congratulations, you have just completed the 4 circuits in Project 1 dealing with light. I want you to look around and see how many things use lights, how many things use LEDs. They're every place, and I want you to consider how you might use them, what you might want to create or build. And next, we're going to look at the circuits in Project 2, which deal with sound. They'll get a little more complicated, we'll introduce some new concepts, and it's going to be a whole lot of fun. Happy hacking, friends!